Chapter 11, Sample Problem Number 7. 5 identical keys are suspended from a balance, which is held horizontally as shown. The 2 keys on the left are attached to the balance 6 centimeters from the pivot. The 3 keys on the right are attached 5 centimeters from the pivot. What will happen when the person lets go of the balance beam? So the implication is, at least in principle, it's unbalanced except for the extra torque that's being exerted by the hand. So if we get rid of the hand, what's going to go on? We're going to talk about what is the force and torque on the balance beam. So the beam looks something like this. Wow, that's terrible. That was a terrible beam. Let's try again. There we go. There is a pivot, the pivot force. This is basically this little dot, which is pushing or pulling up on the beam. We assume at the center. I'm going to call it S sub P. And then we have 2 masses times G. That's the weight of the keys on the side at 6. And we have 3 masses at a distance 5. So we're not going to talk about the forces. We can do it. We can say if we looked at the sum of the forces, we would have minus 2 mg minus 3 mg plus the force of the pivot. And I don't know the force of the pivot, but we would assume it would be whatever would be necessary to give us 0 motion, because we assume that the entire center doesn't move up or down. This doesn't go flying off the table or anything like that. But not helpful, because this doesn't really tell us very much. The other thing we can do is we can say the sum of the torques, and that's going to be, well, we have the 2 chain is going to try and rotate the whole thing this way. Which means that that is a counterclockwise torque and is positive, and it's going to be 2 mg times the 6 centimeters. And then we'd have the other guy, but these are going to try and move the bar. These are going to try and move bar this way. I'm going to swing the bar that way. That is clockwise, which comes in as a negative. They have strength 3 mg, and then of course they're at distance 5 cm. So we get something like 12 mg centimeters minus 15 mg centimeters, or minus 3 mg centimeters. Mg centimeters is just going to be our weird unit of torque here. We don't really care about it. What we care about really is that minus sign, because we know that this is also equal to I alpha. And since I is always positive, it really means that alpha is less than 0 in this case, which means that it rotates clockwise. So we get what will happen is clockwise rotation.